All right, guys, this is the June 2016 Regents exam. I'm starting with question 1, obviously, and I've got my calculator. I've cleared it. So just a reminder of what you have to do to the calculator is turn the diagnostic on. So you want to hit second 0, and then you are just going to scroll all the way until you get diagnostic on. It takes a second. Let's see here. So I want diagnostic on. I'm going to hit enter and hit enter again. So that's all done. And now I'm ready to go for the Regents. Okay. Question 1. The expression is equivalent to, well, if you notice, I have 4 choices here and all of them have been factored. So I want to look at my original problem. And in this case, I have DOPS. I have difference, that's subtraction, of perfect squares. 16 is a perfect square, and I have an even exponent. So if I were to factor that, I'd have 1 plus, 1 minus. I take the square root, and the square root of x to the 4th is x squared. And then I take the square root of 16. That's a 4. And now I just have to find my choice, get rid of these. These all have 8s. And I want x squared plus 4, x squared minus 4. Choice 3 is my answer. Second question. An expression of the 5th degree is written with a leading coefficient of 7 and a constant of 6. Okay, let's break all this down. 5th degree means that the highest exponent is 5. Okay, so that means that I have an x to the 5th because that's my highest exponent. The leading coefficient is 7. So that means if this is my highest exponent, then the coefficient in front of that is a 7. And a constant of 6. That means that I have a plus 6 somewhere at the end. I might have something in between, but I have a constant of 6. That means I have a 6 with no x's. So I'm trying to find something that has this at the beginning and this at the end. And choice 4 it is. Question 3. The table below shows the year and the number of households in a building that had high-speed broadband internet access for which interval of time was the average rate of change the smallest. Average rate of change, we keep seeing this, that means slope. So I need to calculate the slope for all these different intervals. Now, if you look at this, number of households and the years, what do we always do? Slope is change in y over change in x. Or slope is y2 minus y1 over x2 minus x1. That's my slope formula. Now remember, when you have a table, anything dealing with time is always your x. So in this case, time is being measured in years. That's x. Here's my y. So for the first choice, I need to go from 2002 to 2004. So that's 2002 to 4. So I'm going to do 23 minus 11 over 2004 minus 2002. And let's see what we get. And I get a 6. So now I have to do it for choice 2. So I'm going to do from 2003 to 2005. So I'm going to do 33 minus 16 over 2005 minus 2003. Go to my calculator. And I've got 17 over 2. So I'm just going to see, let's see, 17 divided by 2. That's an 8.5. Choice 3, 2004 to 2006. So these are the values that I need to subtract. So 42 minus 23. So 19 divided by 2. And that's going to give me a 9.5. And then last but not least, 2005 to 2007. So I have to subtract. Oops. 2007 minus 2005. Let's see, what do I have? 47 minus 33 over 2007 minus 2005. I've got a 7 here. So they asked me for which one has the slope that's the smallest. That would be choice 1, because that gave me a slope of 6. That's the smallest slope that we have. Okay. Question 4. The scatter plot below compares the number of bags of popcorn and the number of sodas sold at each performance of the circus over 1 week. Which conclusion can be drawn from the scatter plot? Okay. First thing I noticed that we're talking about correlation. All right, correlation has to do with the line of best fit. So if I look at this, if I try to sketch in a line of best fit, probably be something like that. Okay. Let's see what choice 1 says. There's a negative correlation between popcorn sales and soda sales. That is false, because this line, it says negative. Well, this line has a positive slope. As I move from left to right, this line is going up, so that means it's positive. What that means is that as popcorn sales go up, so do soda sales. Correlation, if it's negative, one would go up and one would go down. But in this case, both are going up, so that's positive. So I'm going to get rid of that. Choice 2. There's a positive correlation between the popcorn sales and soda sales. Ooh, I'm keeping that because that one sounds good right now. Choice 3. There is no correlation between popcorn sales and soda sales. Okay, if there were no correlation, there would be points scattered all over this graph, and you wouldn't be able to draw a line of best fit because there would be points everywhere. So that's wrong. Choice 4. Buying popcorn causes people to buy soda. Read this carefully. Does it cause me to buy soda, or does it maybe just, is it a coincidence that if I buy popcorn, I might buy a soda with it? It's not as if when I buy popcorn, I'm forced to buy a soda. Choice 2 it is. Question 5. The Celluloid Cinema sold 150 tickets to a movie. Some of these were child tickets and the rest were adult tickets. A child ticket cost $7.75 and an adult ticket cost $10.25. If the cinema sold $14.70 worth of tickets, which system of equations could be used to determine how many adult tickets A and how many children tickets C were sold? Okay. First thing I noticed, all of these pieces of information that have money should be in one equation together. So these 3 numbers should all be in one equation together. 1025, 775, 1470. That looks good. Look down here at choice 2. 1025, 775, and 150. Look at this 150. That's not a dollar amount. Get rid of that right away. This is money, money. This is not money. So I got to get rid of that. Looking over here at choice 3, money, money, money. Keep those together. Choice 4, money, money, not money. Get rid of it. So right away I'm down to 2 choices. So now $7.75 is the cost of a child's ticket, so $70.75 should be multiplied by C, $10.25 by A. This is the one I'm looking at right here. And then the A plus C, that's just all my adult tickets plus all the child tickets equals 150 tickets. That has nothing to do with money. Here's all my money information in the second equation. Okay, question 6. The table below. The tables below show the values of 4 different functions for given values of x. Which table represents a linear function? First thing I want to notice about these 4 tables is that the x's are all the same. All of the x's are 1, 2, 3, 4 for every single table, so I don't even have to pay attention to that. The y values, that's what I want to pay attention to. Look for the pattern. For me to get from 12 to 19, I have to add 7. 19 to 26, I have to add 7. 26 to 33, add 7. Let's see what happens on the next tables. -1 to 1, I'm adding 2. 1 to 4, I'm adding, or excuse me, 1 to 5, I'm adding 4. 5 to 13, I'm adding 8. 9 to 12, I add 3. 12 to 17, I have to add 5. 17 to 24, I have to add 7. -2 to 4, add 6. 4 to 14, I add 10. 14 to 28, I add 14. If you want a linear function, then you should be adding the same thing every single time. So choice 1 is your answer. The other thing you can look at, you have 4 tables here. 3 of them are changing, 1 of them is staying the same. Pick the one that stands out. That's the one you're looking for. 7. The acidity in a swimming pool is considered normal if the average of 3 pH readings is defined such that P is in between 7.0 and 7.8. The first 2 readings are 7.2 and 7.6. Which value for the third reading will result in an overall rating of normal? Well, if I want an overall rating of normal, then I want all 3 readings to be in here. The first 2 are already in here. So that means that the third reading should also be in between 7 and 7.8. There's my answer. What you want to think about, what if one of the readings was down here around a 6? Okay? If you had one reading that was down low, then you would want a third reading that was up high so that it averages to the middle. Okay? So you got to just pay attention to this. Both of my first 2 readings were already in the middle, so the third reading has to be in the middle. 8. Dan took 12.5 seconds to run the 100-meter dash. He calculated the time to be approximately. Okay, so notice what they're doing here. We have a time in seconds, and they're asking us to change it to minutes or hours. We don't know which one is the answer. Well, if he ran it in 12.5 seconds, then to convert it to minutes, which are my first choices here, I'm going to divide by 60. Okay? Because there's 60 seconds in a minute. So when I divide, let's see what I get. .2083, and when I divide by 60, that's minutes. Let me see if that's a choice. And it is. That's choice 1. Okay? Let's say they didn't have these answers here and they had something else. If I had to then convert to hours, I would have to divide by 60 again because there's 60 minutes in an hour. So you just keep dividing by 60 to get what you want. Question 9. Solve for x. Solve the inequality. Okay, first thing I'm going to do is distribute. Move over here and do some work over here. So I have 3x plus 2 less than or equal to 5x minus 20. Subtract 5x. Subtract 2. And I'm going to divide by -2. This is the biggest step right here. When I divide by a negative, I have to flip my inequality, and I get that. X is greater than or equal to 11. There's my answer right there. Question 10. The expression is equivalent to, okay, so once again, I have to distribute. When I distribute the 3, I get 3x squared minus 3. Now I have to distribute a negative. Minus x squared plus 7x minus 10. So that's all my distributing. Now I have to combine like terms. 3x squared minus an x squared. And then, let's see here, plus 7x. Nothing to combine with that. Negative 3 minus 10. And choice 2 it is. Question 11. The range of the function is all real numbers. Alrighty. So we have to find the range. In order for me to find the range, remember this is an x squared, that's a parabola. So my graph looks something like this. Remember, it's a positive x squared, so that's a positive parabola. In order for me to find the range, I need to find the vertex, which is also called the turning point. Okay? So what I'm going to do is I'm going to go to my calculator. I'm going to go to y equals. Type in my equation. Go to the table. The turning point is in the center of the rainbow. So I'm going to look for that rainbow. Start to see, I think I passed it. It looks like right here, -1, -9, that's in the center, because you can see I have -8s around it and then -5s. So there's my turning point. It's right in the middle of the table. It's in the middle of the rainbow. -1, -9. Now, range means all the y values. So if you look at this, this has nothing to do, because if I want the range, I have something to do with that -9. So immediately cross out choices 3 and 4. They're focused on the x values. Well, we don't want that. We're talking about the range. So it's something with the -9. And if you look at this, are all of the other y values in the table bigger than -9 or less than -9? Well, as you continue to scroll, look at these numbers. They're all bigger than -9. So you want the range is all numbers greater than or equal to -9. There's your choice. 12. The zeros of the function. Remember, zeros are when y equals 0. So that means 0 equals x squared minus 5x minus 6. So I can factor this. Bigger number is negative. I need two numbers that multiply to 6 and subtract to get me a 5. So I'm going to use 6 and 1. The bigger one goes first. Split and solve. So I've got 6 and -1. The other option I have for this question, if I go to my calculator, I can type it in. Oops, x squared minus 5x minus 6. If I go to my table, go find where the y's are 0. So where y is 0. So there's my -1, and there's my 6. Now remember, the zeros are when y is 0. Don't look at the x's. Go to when y is 0. And that's how you get those answers.